Hello engineers! Welcome to SystemDesign.us YouTube channel where we conduct distributed system design mock interviews. Our interviewers are senior FANG engineers and we also have a course at SystemDesign.us. Please listen the entire interview and visit SystemDesign.us for feedback to understand what went right and wrong. We also suggest actionable solutions to get better at designing systems. And don't forget to subscribe to our YouTube channel and click that bell icon so that you do not miss any new interviews.
Yeah, so I've posted my question here. If you do you see the question?
What you are saying is you want to design a alerting system, design an alerting system which monitors all the logs of various system components. System allows user to add custom rules for alerts. If any of the rules is satisfied, system creates an alert. This alert can then be consumed by various sources. Alert can also be viewed by user in detail, so the user can make a necessary change to the system. Okay, so this is something looks like our monitoring system, like where it reads the log based on some error rate or something, right? You configure some thresholds if it exceeds those number of errors, right?
That's right. Yes.
Then you publish a message, like you can alert a message. Basically, that alerted message, there may be multiple channels who will be listening to those messages, right? And they can send via an email or any messaging, mobile message or something, right? Okay, got it. Okay.
Before you go further, do you want to give me a little bit of your background, like how much experience do you have and what kind of position you're interviewing for?
Yeah, so have around 17 years of experience. Okay, I'm currently an engineering lead.
You're looking for another engineering manager position somewhere else?
Yes, engineering lead. Yes, engineering lead.
Okay. Okay.
Yeah.
All right. Yeah. Please go ahead with your design.
Yeah, sure. So what the system does is here, the system reads the logs, right? And capture stats. Okay, correct?
Sure.
Second thing is based on predefined constraints or rules, right? It evaluates constraints based on the data which captured from logs, right? And creates alerts, correct?
Yeah.
That is one thing. Also, do we have the requirement like where user create a constraint?
Yeah.
User create a rule or constraint, whatever it is, right?
Yeah.
Fourth one is so do we need, like when I say a rule, right? It goes on some metrics, right? Like I say like the number of errors, right? So you might be defining a fields, right? So user can create, you can say something called, what's the best word to use? Terms, right? He can define, like we can say, right?
What? Can you repeat that last part?
Yeah, terms, like say example, HTTP error code, right? So that is HTTP.
Okay, so string terms basically.
Yeah.
If that string term appears in logs, then create a rule around it.
Yes.
Makes sense. Yeah.
Yeah. So there will be multiple fields, right? So you don't read means you don't read the constraints and all, right? So you go on specific terms, like say HTTP error code or any specific error you're looking for, or any occurrences of some pattern or something, right? So I'm just saying, like, we can go simply, we can say user creates an HTTP code or something like where you can see that in there. Okay.
Yeah. Makes
So
sense.
what else? So these are the things I see. What I understood is you read the log and you look for those terms in that log, and you apply these values of in whatever the term you created. Like suppose you're looking for HTTP occurrence code like 500, right? So I say if HTTP is code count is like the 400, which is repeated like greater than like 1,000 times, which is like a threshold, right? So you create a rule like that, and you generate alerts.
Makes sense. There could be rules using dates as well, dates and timestamps.
Okay.
Right?
Correct. Create a rule. So those you can create as a terms, right? So I can create any number of terms like start date and interval or something. Right?
But then those would be non-string, right? Because dates won't be really string.
Oh, you mean like predefined? Okay.
Because there are many rules where you say, hey, if these many number of things occur during this time period, let's say during the day, then alert. Or if these many instances of such log happens during the night, then alert.
Okay.
So all of those cannot be just string terms, right?
Okay.
Yeah.
Yeah. So that will be the part of rule itself, right?
Okay.
So when I say user creates a rule, that's part of the rule itself.
Okay.
So some of them are predefined, some of them you define. Okay. So user creating, we will make it simple other case if we have so many things, right? Like let's make only like 3, right? Create a rule that that goes based on the metrics, right? So metrics of any errors or something. So do you need anything else? Like all these are covered or like?
I think that's good. Let's start. Yeah,
okay.
You can start with the design.
Okay. So non-functional requirements. So is there anything? Okay, that's covers. So what we were looking in about non-functional requirements. So do we need to like do any refreshing, means clean up data or something like that, or that's comes under like
No, I don't think we need to worry about that.
Functional requirements. Okay, so the load and everything.
But cleaning up data would actually be an example of functional requirement, right?
Yes. I'm thinking about the load and right. I think it's a bad job. I feel it's more like a batch, right? I don't think we really worry about that. Only the problem is like the number of files, the number of log files that we are going to. So are we like we are thinking about like it's a distributed?
Yeah. Yep.
Okay.
So many different services, many different distributed services are submitting their logs to this service or to this system rather. And this system needs to provide this functionality of, accepting these logs, monitoring these logs, allowing users to add rules on top of these logs, and then actually use those rules to alert.
Okay. So let's come to the non-functional in case we require. Will come at the end. Is that okay?
Yeah.
Okay. Okay. So now what I see is right. This is what I see. Okay. So so coming to the services, right? this service looks is we have multiple things here. One is I see create rule service, okay, which will take we can say all the metadata, whatever the metadata rule, we can say an object, okay.
Okay.
That is we can say it's an entity, we can say rule object.
Are you creating an API or what exactly is this?
Yeah, this is a service which allows the user to create a rule, right? So you want to concentrate all the rules are exist. You are just trying to build analytics, or like so. What I'm trying to ask is, right, what functional requirements you want to focus. So this has multiple things, right? First, the user will create a rule, right?
Yeah.
So
Yeah.
that for that one, I can have an API, right? So where
you can have an API, but it's just this API thing is really not that useful in interviews because APIs are not fixed; they keep changing, especially and plus in these things. What we are interested in is not how others are going to use this system, but how this system is actually designed. Like what are the different pieces in the system is what
So
we're interested in.
got it. So basically, what I do is, right, I gather functional requirements, non-functional requirements, and I try to build up all the services that has to be there to create such a system. Then what I do is, then I define the schema, like how the database, what all the database schemas that I need to use, right?
Okay.
Then I will go with the block diagrams. Like then I will what all the components that we might need to have, right? And then how those
we can do
components.
that. Yeah, we can do that if you want, but we only have so much time, right?
Yeah, sure. We can, if you want, I can explain. But as you said, I'll concentrate more on the implementation, like overall design.
Okay. Let's do that. Yeah.
Okay. So basically,
if it helps you, you can definitely create a list of the services so that you move on to the block diagram. But the API designing is really not that useful, even when you actually design these systems, right? If you were to ask to design this system in a real company, no one really writes APIs, right?
No, it's not API. It's a like high level operations that support it. Yeah, that is the approach we follow. It's like based on interviewer, right? I can concentrate what interviewer is looking for. Let's start. Like, okay, so basically what I see, one of the component I see is, right, so there is some background. So you said it's a distributed system, right? So you will have multiple servers, right? Where you have logs, right? So you can have multiple servers, right? How I can make copy of this? Let me. Sorry, I didn't use this one before, so.
That's fine. Yeah, take your time.
Yeah. So you have multiple servers, right? Okay. This is basically where you have the server logs. Okay. So, so what I will do is, so this is a complete raw data what you see, right? So when you want to build the stats, right, you should have something which is more kind of readable, right? So I have one what you call, I have a background job. Okay. So this background, this one you can say, logs collector or whatever it is. Okay.
Okay.
So what this does is it publishes, it reads this logs. Okay.
Okay.
Whatever the logs which are there, right? It reads these logs. Okay.
So, but
And
then the log collector cannot really read anything, right? I mean, the way in general, the way it works is people post their logs through either some REST API or some other or communication protocol. These servers will post their logs to this
yeah, that
entire
also
system.
fine, right? It's totally, suppose if I am running some agents, right? Suppose if I have agents, right?
Agents within these servers.
Yes, yes. So these agents will publish to the like I have an API. Okay, it's a different way you can do it. Okay, I have an API. Okay,
Okay. Okay.
this the purpose of this service is receives um, messages or messages sent by agents. So these agents, right?
Mm-hmm.
There are two ways this we can define. One is like you have the agents on the server. Okay,
Sure.
this will send, these agents will have all the information about this. You can say this, you can name it as anything like a broker or anything, right? So
Mm-hmm.
these agents will send, this is the typical monitoring tool generally works like most of our typical like Dynatrace or like New Relic, right? So
Mm-hmm.
what they have is like you have the agents, like even Splunk works like that, right?
Right. Right.
So you have the agents, and these logs are means are pushed to the a centralized a broker, right?
Okay.
So
Mm-hmm.
what this does is it will capture all these logs, okay, and
Right.
it will convert that into a metadata, which this is a raw, right? This is a raw data, but what I need is it's a modelized means a structured data, right? Where I can apply the queries or whatnot on that, right? So
Right.
this one will convert into a specific what you call model data, like it puts in metadata, okay? Meta
Mm-hmm.
meta you can say uh, metadata, okay? Suppose in case we all need, right, these files you need, right? Suppose example, you can put in some external repository, the file repository like S3 or something, okay?
Okay.
The metadata about these files are managed here, okay?
Okay.
Metadata and this file, okay? You have like this one, have entry here, you have entry here if you need files, okay? You can just only read it up to like how we want, right? um, if I need, I'm doing this because I need both the information. Suppose if I need both the information, I'll use that one second. This one, okay, this one say a repository which will manage the logs, and this is metadata. Okay. Now
Okay.
what you do is this metadata, you can say it also has the rules that are defined. So it has both. One
Okay.
is whatever the files that you read the logs and you pushed, and it also has some stats. Okay, it builds some stats like, right, the number of errors, right, all those information. So you are
Mm-hmm.
specifying. It has several things, right? Which server ID? Like say we can say what is the server ID? What is the metric? Okay, and what are
Okay.
the uh, errors and all those things. Okay.
Okay.
At the same
Okay.
time, I also have the rules, whatever we define. Okay.
Rules are also part of metadata.
I can use the same database, right? Or you can use separate
Oh,
database.
that's a database. Metadata is a database.
Metadata is like it's like a database.
Okay.
Metadata DB. Okay, that has both the things. So we have schemas related to the rules, and also the service, whatever agents submitted, right? Whatever the captured messages, the important things you structured here and you put it. If you want
Okay.
the logs you want for archival, or if you want to, right, use that, you can put in the repository that entry of, like, you can have this S3 URLs of this particular files, right?
Okay. Okay.
So, and those are the things that are defined. Okay. Now, one more thing is, right, there you can have another uh, job which is running frequently. Okay. You can run for every minute, or like every, like, however you want, right? A scheduler.
Okay.
Okay. So what it does is, the purpose of this one, you can say alerting scheduler or whatever it is. Alert
Okay.
scheduler.
So
Okay.
this is is this a cron job or what is it?
You can take that as a job which continuously run, right?
Okay.
If you want, like, suppose if I want to have a system which you want to, uh, right, immediately you want to, right, if you want to, what you say, create the alert, right, you will
Mm-hmm.
be running, the frequency of this one is uh, very, like, fast. I mean, like every 5 seconds you run it. Okay.
Okay.
um so it so it requires some calculations, right? So whatever the metadata that is there, you evaluate that, right? And then you has to notify. Some
So
has to frequently monitor, right?
right. Yeah, that makes sense. But then you're saying this alert scheduler will read all the rules in the metadata DB and find out which rules are being violated and then alert?
Yes.
But then wouldn't that not work if there are hundreds of thousands of rules?
Okay. So then you will, so in that case, what we can do is, right? Um, okay. So what you are saying, like, you will have, okay, I got it, what you are saying. So what I can do is, okay, then I'll make another way. So what I do is, this is the metadata where you define the rules. Okay. And
Mm-hmm.
this is not exactly a scheduler then. Okay. Now what it does is, you can say a worker consumers. Okay. So you can have this uh, messaging system, Kafka messaging, whatever, a queuing mechanism, where you have multiple uh, messaging queues, right?
Mm-hmm.
So where these messages are published, okay? These
Okay.
messages are, like, published here. Uh, I can have multiple workers, okay? So you can have any number of servers, right? Worker one, it's a consumer basically.
Okay. Yeah.
Then you have worker two, right? This is reads any number of, any huge loader, right? You can scale workers how many ever you want. This one, each and every one listen to these messages, right?
Yeah.
Uh, then they update the uh, stats parallelly here. You can say, assume that These rules are applied here, right? No, sorry. Um, yes. So this each and every worker, like again, you can read the caching, right? Data caching and everything. This message will close here. Okay.
So, but then, so again, the metadata DB is holding all the rules that are defined by users, right?
Correct.
So
Correct.
essentially, these workers are going into the DB and iterating over all those hundreds of thousands of rules and then evaluating which ones are being broken.
So basically, like rules, right? You can so hundreds of thousands of the rules, right? Like when this okay, so you run, yes, you evaluate each and every rule. So some of them are like metrics, like specific to the server and everything. Some of them are specific to the application errors.
Sure.
Yes. So this will run set of rules. Okay. Again, right? This workload, right? You can shard this, right? Suppose you have like 10,000. Suppose assume that you have like 100,000 rules, right?
Mm-hmm.
So
Mm-hmm.
what I can do is I can shard this data into a chunk of rules, like 1,000, 1,000, 1,000, 1,000, 1,000. All right,
Okay.
like whatever it is, 5,000, 5,000, 5,000. Okay.
Okay.
Now
Mm-hmm.
worker one will always see 1 to 5,000 rules. Okay. Worker two always check 5,000 to 10,000. Right.
Mm-hmm.
This way, what you are doing is you are trying to run multiple rules parallelly. Okay.
Yeah.
Suppose if I have only one worker, if it is trying to scan all 10 or like 1 lakh rules, right? Then it's a time consuming.
Right.
But when I do a range based, suppose if I define a key for each and every rule, and that
Mm-hmm.
the key what you define it is segregated around different shards, right?
Okay.
And each worker goes on. Worker one is specific to that particular range. Worker two is specific to 10,000 to 15,000. Worker three is specific to. So this way you can scale any number of workers based on the number of rules. Suppose today, like you have 1,000, you might require like 2 or 3 workers. But tomorrow, you are getting like lakhs of rules. So what I can do is I can scale up these workers, right?
Okay.
So the purpose of worker is only handles the range of rules, right? So that it focuses mainly on that. It doesn't worry about that. Okay.
Mm-hmm.
But then what you have each and every worker, what it does is you can have and again alerting subscribe another queues, right? Right, another queue kind of, sorry, messaging system. Like whenever an alert is generated, these are published to another messaging queues, right? So whoever wants to say whoever wants to subscribe, right? I can tell example like what all subscribers you can have, right? So there is an arrow here. Sorry, I don't know. I'm a little bit having trouble with this. Yeah.
I get the idea. Yeah.
This is another messaging queue. Okay. 1 second. Okay. So now, like email systems, right? There can be another email system. Okay. This is an email system. So email service, whatever, right? This will subscribe to, listens to this alerting system. Okay. So it will take care of sending email. Okay. There is it can listen to all the right queues. Again, these all are like multiple. Then you might have mobile messaging service, right? You have mobile messaging service. This is another service, mobile messaging service, right? This also subscribe to this queues. In the different direction. Right? So it's like whoever is interested, they can subscribe and they can.
Makes sense. Makes sense. So what happens when users come in and they either change rules or delete, add rules? So will that change this worker 1 and worker 2 configuration, or will that just work fine?
So basically these rules are applied dynamically, right? So you define some expressions. Basically the rules what you define, you might convert that into a Postgres mathematical expression, right? Simple example, like simple, you can convert that into a Postgres mathematical expression. So what this worker will do is, it will pull those post expressions and whatever the values that read from this log, right? And other metadata that is there, threshold and everything. So it evaluates dynamically, right? But
then you're saying that each of them will be responsible for a fixed number of, let's say, 5,000 rules, right? So then if some of them were deleted, so then in that case, some workers would be working less, whereas some other workers would be working more, right?
Correct. So you want to say like, so basically, right? When it goes on the range base, right? So I got what you're saying. So what you are saying is like, I have one has 5,000, 1 to 5,000, other has 5,000 to 10,000. Next day, what I do is, in the one in 5,000, suppose I delete 500 records. So the worker one is only handling 1 to 4,500, but whereas the other one is handling like 5,000 to 10,000, right? Okay. So so in that case, it's yeah. So then, like in that case, we need to a kind of a resharding, right? Like you need to reindex, right?
No, you cannot just do that, right? I mean, now once this system is in production, you cannot reindex over and over, right?
Right.
I mean, especially these are like.
So basically, this is a hashing problem. You can use something like consistent hashing, right? When you are doing sharding mechanism, right? And you can use a virtual nodes. So basically, you don't know the number of shards that are required, right? So these number of rules for growing, right? So what you can do is, you can implement something like a consistency hashing.
But it's not, just to cut you off, but it's not a hashing problem, right? Because you are already doing the hashing thing by segregating them into groups of 5,000. The problem is the hashing works fine. The hashing is assigning each of these rules some number between 1 and 5,000. The problem is these workers are doing unequal amount of work. Some of them are underused, some of them might be overused.
Okay, so we can do something like this, right? So now what I do is, I will not go on the range based. Okay, I will not go on the range base. So what I do is basically what you're saying. Okay, so if it is not range based, then it can happen. it can happen. You go randomly to different shards, but when it's going to a different shard, again the problem what happens is same worker can pick same rule, correct?
Yeah.
So that is another problem. Suppose if you want, uh, if I restrict to each worker is associated to the same shard, then you will see the problem. Some will have less, some will have the more. Suppose if I make this is not what you can say, not deterministic. If I say undeterministic, your worker is going to different shards, then the problem what can arrive is the worker can pick the same rule, right? So that kind of problem can arise. So how can we solve that? So we need to uh, we need to uh, then you can use some kind of mechanism, right? One thing is we can say undeterministic. So each and a worker can go to any shard, right?
Okay.
That way, that whatever the problem you said, right, that is solved. Okay.
Okay.
The second thing is for that metadata, whenever a worker picks a particular rule, you can flag. Okay, that is something like it is in progress.
But then now you have a tracking problem, right? How would worker one know which rule has already been, processed by worker two?
Sorry, which, okay, tracking problem. So so what I do is I manage a status. Okay, if it is in progress, if it is trying to pick that, okay, it says already a worker is assigned to it, right? That is how you check, right? So if it's already assigned, then worker will pick the next one, which is not used.
Okay.
Correct?
It sounds okay, but I'll have to think about if that works or not.
Yeah. Yeah. So we have to compromise one or the other place, right? So if you want to make it undeterministic, then there is a good chance same workers will pick same thing. Suppose if you want to be deterministic, then exactly whatever you said is correct. Some will have this one. Otherwise, like what we can do is reshuffle the rules and reassigning the indexes, right? That also we can do it. But that is an extra overhead, right? If we want to make use of effectively use of this one, right? We need to re-index the rules.
To understand fundamentally, are these worker ones and worker twos executing these rules or reading these rules every time they receive a message from the agent? Is that what is happening?
Yeah, so you keep on updating, right? Like suppose what I do is I have a rule, right? Like for that one, I have some threshold, all right? If that rule is satisfied, sorry, if that whatever the parameter, like if I say greater than 500, right? Then you
that I understand.
Yeah.
But what I'm asking is, will that evaluation on every rule happen for every message received by the worker?
Yes, it has to reevaluate, right? So how do we know the threshold, it exceeded the threshold or not, right?
For every message.
Yeah, otherwise how do we know whether the threshold is exceeded or not, right?
I think that might be too much, right? It might be better if the process is driven through the rules themselves, because I think it's unrealistic for any rule to be active on every second of every hour, right? So generally these rules are defined on on an hourly basis or 6 hourly basis or something, or daily basis or something like that. Because
Yeah,
if you start tracking every message on it, because you could be receiving millions of messages per second from multiple
yeah, in that
services.
case, right? In that case, we can here we are continuously. The reason I did like this is like for a real time basis. I want to do it real time. Suppose if it should be a rules driven base, then each and every rule will, like, instead of workers reading the metadata, right? The rules engine will call this workers, right?
Right.
So,
But then in your design, it will work only on a very small scale, is what I'm saying, right? Because once it goes, like, let's say 10,000 messages per second, it just won't work.
Correct. Exactly. I agree. Like, right. So what I thought, it's like for real time, that's the reason I went, but you can do that approach. Exactly. We can do that. So instead of we monitoring, let the rule, like, suppose say every 15 minutes, right? The last 15 minutes. Okay.
Yeah.
So when I say in the last 10 minutes, so every 10 minutes that rule will be, means it will call the worker, like the rule will call the worker. What the worker does is it evaluates at that particular point of time, and it gives the result back to that the alert, right?
Yeah.
So
Yeah.
there again, like, alert, that system will send the, like, instead of post, like we can say like a pull kind of model, that will post the messages to the queues, and the email service and mobile messaging service will read that.
It'll be a different approach to the service.
Yes.
Designing this problem. All right.
Right.
I guess we're almost running out of time here. I wanna give you a chance to ask me any questions if you have any.
Thank you for watching, and don't forget to visit systemdesign.us for more questions and solutions. Please subscribe to our YouTube channel and click that bell icon so that you do not miss any new updates.